Hi and welcome back to tutorial number 13 on mathematics. We're going to be talking about things like unit conversion, converting micro to pico to nano to micro and to kilo and megahertz and so forth. Normally you enter very large numbers and very small numbers by using scientific notation on your calculator. Rather than learn that, I'm going to be explaining how you can do it without it, but I'll also spend a little bit of time explaining how to use scientific notation on your calculator as well as we go through some of the drill questions. This will be a light treatment of mathematics for the standard license because the standard license does only need light mathematics. If you're troubled and want to do more on maths and the use of a scientific calculator, I'd suggest you log into your Res account and get the mathematics course with the school's scientific calculator is probably the best way to go. But if you can deal with the mathematics we're about to go through, then you have no need to do that. When we're dealing with very large numbers and very small numbers, we use what is called scientific notation. Now, if this troubles you, you don't have to do it. I'll be showing you how to do it with normal fractions as well. But in radio, we have a number of units subunits and other units that describe easily large and small numbers to us. Now, for example, one that you would know about already would be kilo. That's one you should know. For example, a kilometre is 1,000 metres. So instead of saying 10,000 metres to get somewhere, we just simply say 10 kilometres, 10 kilometres, because kilo means 1,000. So that's one that you should know. And mega above it means a million. And these exponents next to it tell us how many zeros mega and kilo have. Mega is capital M, kilo is lower m. 10 to the 6 means 6 zeros. 10 to the 3 means 3 zeros. So 10 to the 6, 1, 2, 3, 4, 5, 6 means a million. 10 to the 3, 1, 2, 3 means 1,000. The other one that you would deal with in amateur radio, but not so much in your assessment, is giga. Which is 10 to the 9. And 10 to the 9 means 9 zeros. 3, 3, and 3 is 9 zeros. And as you can see, they go up. Tera, peta, exa, zeta, iota. I wouldn't worry about those at all. I wouldn't worry about giga too much, but I'd certainly make sure you understand that mega means a million times, kilo means 1,000 times. Now, going smaller, the important ones for us are this block here, milli, micro, nano, and pico. You will find a PDF file containing this document only in the document folder on your DVD. Okay, milli is 1,000th, which is 0.001. 0.001 is the same thing as 1,000th. So milli means 1,000th. Micro means 1,000,000th because there are 6 places after the decimal point. 1, 2, 3, 4, 5, 6. That's a millionth. Milli is a thousandth because there are 3 places after the decimal point. 1, 2, 3. 1, 2, 3. 1,000th. Nano is a thousandth of a millionth. At 1,000th of 1 millionth. Pico is a millionth of a millionth. So the smallest here is pico. It takes a million picos to make 1 micro. It's much bigger. It takes 1,000 picos to make 1 nano. So they're the ones that you need to, and I'll be showing you how to put those figures into the calculator. So if you want to put 12 micro farads into a calculator, you can tell the calculator whether it's microfarads, nanofarads, picofarads, etc. If we wanted to put 12 microfarads into the calculator, we can just put in the 12 and then we can tell the calculator that it's micro, and that saves us putting in a whole lot of zeros. But if you have trouble doing it that way, don't worry too much. I'll show you how to do it with fractions as well. And don't forget, you'll find this document in your document folder as a PDF file. I think it's called scientificnotation.pdf. These are the important ones, the important prefixes, suffixes for the standard exam. When we're dealing with very large and very small numbers, we have to use abbreviations such as pico, nano, micro, milli, kilo and mega. One that you're very familiar with is kilometres. We don't say we're going to drive 5,000 metres. We say we're going to drive 5 kilometres because kilo means 1,000 and the symbol for kilo is an uppercase A. All the numbers above 1, that's kilo, mega and giga, we normally put the letter in uppercase, and below 1, milli, micro, nano and pico, we put a lowercase letter. There is an exception with kilo. For some reason, if it's kilohertz, for some reason a lowercase kilo is used like that. So just be aware that kilo should be shown in uppercase, but more often than not it's shown in lowercase. So starting with the smallest one, pico, a pico of something, a picoamp, is a millionth of an amp. That's very, very small. We use pico for current, we use it for capacitance a lot, but it's a millionth of whatever you're measuring. So if it's a picoampere, it's a millionth of 1/1,000,000th of an amp. Nano is a thousandth of a millionth. So if you have 1 nanofarad, you have 1,000th of a millionth of a farad. Micro is a millionth. So a microfarad is a millionth of a farad. Milli is a thousandth. So 10 milliamps is 10 1,000ths of 1 amp. Kilo is 1,000 times. 5 kilometers is 5,000 kilometers. Mega, a megaliter of water is 1 million liters of water. A gigaliter of water is 1,000 times more than a megaliter of water. It's 1,000 million liters of water. It's rather awkward to write down a millionth of a millionth, a thousandth of a millionth, and a millionth, and so on. It's very difficult to write down big numbers like that. So we have a shorthand technique for writing them down. The shorthand technique for writing pico is 10 to the power minus 12. That should be a superscript. I'll superscript that in a moment. But it should be 10 to the minus 12, because 10 to the power minus 12 means 1 millionth of 1 millionth. Why? Because there are 12 zeros there. That makes it a millionth of a millionth. And the shorthand technique for writing pico then is 10 to the power minus 12. How many zeros are there in nano? There's 9, and it's smaller than 1, so it's 10 to the power minus 9. I might just see if I can tab those across, get them nice and neat for you. And micro is, you should be able to work it out by now, it's less than 1, so it's minus. There are 6 zeros, so it's 10 to the power minus 6. Oops, 10 to the power minus 6. Milli, you should be able to work it out, 10 to the power minus 3. And kilo, well, this is above 1, so it's 10 to the power 3, not minus 3. I'll superscript those in a moment. Mega is 10 to the power 6, and giga is 10 to the power 9. Let me just superscript these. A little bit slow, sorry about that. I might be able to do it quickly. Superscript. Okay, try and use... that's how they're normally written, with a superscript like that. So pico equals 10 to the power minus 12, nano 10 to the power minus 9, pico is the smallest, micro 10 to the minus 6, milli 10 to the minus 3, kilo 10 to the power 3, mega 10 to the power 6, and giga 10 to the power 9. Now I'm going to show you in a moment how to put so many picohenries, so many nanofarads, so many micro whatever into your calculator. You do not have to do this for the standard exam, although it is an advantage to you if you know how to do it. But if you have difficulty with it, I'll show you how to use it with fractions as well. And you will also need a scientific calculator with an exponent key. Now the exponent key has normally got EXP on it or double E, because the exponent key is what enables us to enter these numbers. And what I'll do is I'll put up a few on the screen and show you how to enter them into my soft calculator. Suppose you wanted to put 25 picofarads into your calculator, and I've made up some values for all of them here. But if you wanted to put 25 picofarad into a scientific calculator to do a calculation with it, you can't just type in 25 and then do a calculation, because it's not 25, it's 25 picofarads. So you need to tell the calculator that it's 25 picofarads. So you would enter 25 into the calculator, then you would press the EXP key, and then you would have to say it's minus 12, because pico is a millionth of a millionth. That's 12 zeros, so it has to be minus 12. Now different calculators have a different minus key. It's not the takeaway key. Some calculators have a minus key for use with exponents in brackets. Some have a plus minus key, and you use that to get a minus sign next to the exponent. So I'm going to use this one. So it's 25 exponent minus 12. That's how you put 25 picofarads into the calculator. And then if you wanted to, you could multiply it by something if you chose. Nano is a thousandth of 1 millionth, and that's too big of a number for us to manipulate in the calculator, so we would type in 50 into the calculator, press the exponent key, press the minus key, and then nano is a thousandth of a millionth, that's 9 zeros, so it's 9. Micro, so 100 microamps would be entered into the calculator, 100, exponent, either minus or the plus minus key, and it's minus 6. Milli would be 16, exponent, minus 3, because it's a thousandth. 3 zeros in a thousandth, so it's minus 3. The minus says it's a thousandth. 50 kiloohms would be entered. You could enter in 50 if you wanted to. You could enter in 50,000 ohms. A better way is 50 exponent. It's not minus now because it's above 1, 3. Because kilo is 1,000, means 3 zeros. Mega, 10 exponent 6. Not hard, is it? And giga would be 1 gigabyte would be 1 exponent 9. And there you go. What I'm going to do in a moment is some quick calculations on my soft calculator. If you have trouble with this, just move on and go through the rest of the tutorial, because I will show you how to do them using fractions as well. But in a moment I'm just going to get my calculator out and show you how to do some quick calculations using some of these that are on the screen at the moment. I've got a problem on screen. We're going to use the equation I equals E over R, the basic Ohm's law equation, but the voltage is 25 millivolts and the current is 5 microamps. So I equals E over R comes down to I equals 25 millivolts divided by 5 microamps. Now let me show you how I would do that on my calculator. So we're going to have to do the division, 25 millivolts divided by 5 microamps. Here's the calculator. Always press all clear on your calculator before you do any calculations. Now we're going to enter 25 milli. Now milli is 10 to the minus 3. So 2, 5 exponent minus 3. What we've done here is put 25 millivolts into the calculator. Now we have to say divide by 5 microamps. Micro is 10 to the minus 6, a millionth, 10 to the minus 6, so it's 5 exponent minus 6, and we press equal to get our answer, and the answer is 5,000 ohms, 5,000 amperes. I'm going to do at least one more of those. Okay, this time we're going to use the equation XL equals 2 pi FL. You won't have to do this in your exam. This example is just to show you how to use the exponent key on your calculator, and if you haven't got one, don't worry about it. You'll have to use a different method, which I'll discuss shortly, to do some of the maths in the standard exam. So XL equals 2 pi FL, and we're told that F is 1.2 megahertz. That's 1.2 exponent 10 to the power 6, and L equals 100 microhenries, which is 10 to the minus 6. So it's 1.2 10 to the power 6 for mega, 100 by 10 to the minus 6 for micro, and the equation becomes XL equals 2 pi by 1.2 megahertz by 100 microhenries. Now let me show you how I would do that on the calculator. Press all clear, always, and I'm going to enter in 2 pi. 2 multiplied by, I've got to press the shift key to get pi. So I've entered in 2 pi multiplied by, we've entered in the multiply, 1.2 megahertz, 1.2 exponent 6 is megahertz, multiplied by 100 microhenries, 100 exponent 10 to the minus 6 exponent minus 6 equals, and it's approximately 754 ohms. Okay, I'm not going to labour on scientific notation. You can get away without it. If you insist on knowing more, I'd recommend you get the school's mathematics CD and the school's calculator, because all of our examples are using the hard Casio calculator. Or you can get your own calculator, but if you do, I would strongly suggest you get a high school Casio calculator. Okay, shortly we're going to be going through some typical examination questions which require unit conversions and a little bit of mathematics as well. Rightio, we're going to have a look at section 10 on mathematics of the sample questions. To test yourself on these questions, you can use drill number 10. First question, 10.1. And these are very, very typical of the sorts of questions you're going to get in your assessment. To convert microfarads to picofarads. Well, a picofarad is a millionth of a farad, and a microfarad is a millionth of a farad. Therefore, a microfarad is a million times bigger than a picofarad. A micro is a millionth, a pico is a millionth of a millionth, so micro is a million times bigger than pico. So to convert micro to pico, you would have to multiply by 1 million. Question 10.2, to convert picofarads to microfarads. Picofarads are a million times smaller than a microfarad. So to convert picofarads to microfarads, you would need to divide by 1 million. Question 10.3. 1 mega means a million. 1 megahertz is the same as, well, 1 megahertz would be 1 millionth of a hertz, and answer A is 1 millionth of a hertz. So that's not right. 1, 2, there's not enough zeros there. 1 megahertz is the same as 1,000 kilohertz is the answer. Kilo is 1,000, so that's 1,000 thousands, which is a million. So 1 megahertz is the same as 1,000 kilohertz. Question 10.4. 1 milliwatt. Milli is 1,000th. Micro is a millionth. So is 1 milliwatt larger than 1 microwatt? It certainly is. Milli is 1,000th. Micro is a millionth of a watt. It's certainly not smaller than microwatt. It's certainly not larger than 1 watt. And it's certainly not equal to a millionth of a watt. So 1 milliwatt is larger than a microwatt. Question 10.5. 1 kilohertz is the same as, Or kilo means 1,000 hertz, so 1 kilohertz is 1,000 hertz. Question 10.6. 1 microhenry is certainly not larger than a millihenry. It is certainly smaller than a millihenry because micro is a millionth, milli is a thousandth, so a microhenry is certainly smaller than a millihenry. It is not larger than a henry, and it is not equal to 1,000 millihenries because that would be much, much larger. So the answer is B. 1 microhenry is smaller than a millihenry. Question 10.7. 100 picofarads is the same as we've got to convert picofarads to microfarads. So we need, a pico is 1,000,000 times smaller than a micro, so we need to divide 1,000,000 into 100 picofarads. So let's write 100, and now let's divide that by a 1,000,000 by moving the decimal place 6 places to the left. So that's 1, that's 2, that's 3, and I'll put a decimal point in, 4, 5, 6. So 100 picofarads is the same as 0.1 microfarads. I'll do that again. We start with 100 picofarads. Now we need to divide by 1,000,000. We do that by moving the decimal point 6 places to the left and adding zeros. That's 1 place, that's 2 places, that's 3 places, and I put a decimal point in. That's 4, 5, 6. So 100 picofarads. Oh, I marked the wrong one then, didn't I? Is 0.0001 microfarads. Glad I picked that up. Question 10.8. To convert farads to microfarads, well, if there are 1,000,000 microfarads in a farad, so you would multiply farads by 1,000,000 to get microfarads. Farads multiplied by 1,000,000 gives you microfarads. Question 10.9. A millifarad is smaller than a microfarad? No way. A milli is 1,000th, micro is 1,000,000th. Larger than a microfarad? It certainly is. It's 1,000 times larger than a microfarad. Smaller than a picofarad? It is not. Larger than a farad? B is the correct answer. A millifarad is larger than a microfarad. Question 10.10. A picofarad is larger than a microfarad? That's not true. Smaller than a microfarad? That is true, because a pico is 1,000,000th of a millionth, a micro is 1,000,000th, so a pico is 1,000,000 times smaller than a microfarad. It's certainly not larger than a nanofarad. That's 10 to the minus 12, 9. Pico is 10 to the minus 12, and it's certainly not larger than a farad. So a picofarad is smaller than a microfarad. Question 10.11. 1 milliampere is larger than a microampere? Well, milli is 1,000th, micro is 1,000,000th, so that is true. Smaller than 1 microampere? No, it's not. It's 1,000 times larger. A milli is 1,000 times larger than a micro. It's not larger than an ampere, and it's not equal to 1,000,000th of an ampere. That's a microampere. So 1 milliampere is larger than a microampere. Excuse me. Question 10.12. 1 milliwatt is larger than a microwatt. A milliwatt is larger than a microwatt. Milli is 1,000th, micro is 1,000,000th. So that is true. A milliwatt is larger than a microwatt. Smaller than 1 microwatt? No, it is not. It's 1,000 times bigger. Larger than a watt? It is smaller. Equal to a millionth of a watt? No, it's 1,000 times bigger than that. A milliwatt is larger than a microwatt. I'm just going to page the next question down so we can see it all on one page. 1013. The current drawn by a 500 volt power supply which produces 10 watts is... Well, you will have access to a formula sheet in your assessment. We're trying to find current when we know voltage and power. I equals P divided by E, and that equals, power is 10 watts divided by 500 volts, and if we wanted to, we could change it to milliamps by multiplying by 1000. That would give us milliamps. And if we did that, we would get, if we did the calculation, we'd get 20 milliamperes. But I'll show you on the calculator. You can do it in your head too. All clear. So we're saying 10 watts divided by 500 volts equals 0.02 amperes, but now we want to convert it to milliamperes, and to do that we multiply by 1000 because all the answers are in milliamperes, multiplied by 1000 equals, and the answer is 20 milliamperes. Question 10.4. The power generated by a 500 volt power supply drawing 20 milliamps. So I've given you the equation. You can look it up in the formula sheet. P equals E by I. That equals 500 by 20 milliamps, and I'm going to use the scientific method. You could put 20 over 1000 instead of 20 milliamps and use a fraction, so it could be 500 multiplied by 20 over 1000, but I'm going to use scientific notation with this one. I'm going to clear the calculator. I'm going to enter 500 multiplied by 20 milliamps. Now I have to put in the milli, 20 exponent minus 3, and to get my answer I just press equals, and it's 10 watts. Just scrolling down. This graph shows the relationship between current and voltage in a DC circuit. You'll notice that as voltage and current change, if you graph it, it's a linear line, a straight line, because current is directly proportional to voltage. That's why the graph of current versus voltage is a straight line. So we want to know resistance, and we're being told we've got 10 volts and 125 milliamps. So R equals E divided by I, and that equals 10 divided by 125 milliamps equals. Now you could say 10 multiplied by 125 over 1000 would give you the same answer as I'm about to get, but I'm going to enter it in the calculator. So 10 divided by 125 milliamps. 125 milli is exponent minus 3 equals, and the answer is 80 ohms. Now we've got to do some decibel ones. You don't have to do a lot of decibel calculations. In fact, if you're prepared to learn what ratio different decibels are equal to, because a decibel measures the ratio between two power, current or voltage levels. However, in the standard exam you will only get questions on with decibels in relationship to power. So we're told that transmitter has its output increased by 3 dB. We want to know the numerical increase. Is that an increase of 10 times? Is that an increase of 5 times? How do we convert 3 dB into a numerical increase? I've given you the equation. AL stands for the anti-logarithm. So the numerical increase, I'll write it down, equals the anti-logarithm, and I'll type the full word, of the number of decibels. The number of decibels we've got is 3 divided by 10. And I didn't spell numerical very well, did I? And of course that will equal the anti-log of 0.3. I'm just being lazy with my typing. So 3 into 10 goes 0.3. Now we have to find the anti-log of 0.3. And for that you're going to need a calculator, unless you have memorized, and you can do this for the standard exam because there's only a few decibel quantities used and you will see them all in this tutorial. So I'm going to do this calculation, the anti-log of 0.3 on the calculator. All clear. So I want the anti-log of 0.3, so I enter 0.3. There's the log key on my calculator. To get the anti-log I have to go shift, and that will give me the anti-log. Sometimes you have to go shift, sometimes you have to go second function log, sometimes you have to go inverse log. So I go shift and press anti-log, and it gives me 1.995, which is close enough to 2. So the answer is 2. Three dB is equal to a doubling of power. Minus 3 dB is equal to a halving of power. Decibels measure the ratio of two power levels. Moving on, and we'll be talking more about decibels later on as well. Moving on to, I'll just page down this so we've got it all on the one page. A ratio of 10 expressed in decibels. Well, the equation, if you know the ratio, let me explain what I mean by ratio. Let's say we had 1 watt and we're feeding that to an amplifier, and that amplifier is giving us 10 watts output. Well, that is a numeric ratio of 10. So it wouldn't matter if it was 1 watt and 110 or 10 watts and 100. It's still a ratio of 10. It could be 1 milliwatt and 10 watts. That's still a ratio of 10. So I've given you the equation. dB equals 10 times the log of the ratio. So we need to find the log of the ratio and then multiply it by 10. Let's do that. And the answer should be 10, because 10 dB as a power ratio has a numeric gain of 10. Now, if you choose, you can remember that 3 dB is a doubling or halving, minus 3 dB is a halving, 10 dB is an increase of 10 times, or minus 10 dB is a reduction to a tenth. But anyway, let's do 10 log of the ratio on the calculator. All clear. So we're going to find the log of the ratio. The ratio is 10. So we go 10, get its log, and then multiply by 10. And by the way, the log of 10 is 1. Multiply by 10, and the answer is going to be 10, of course. So 10 dB as a power ratio, the 10 as a numerical power increase equals 10 decibels. 10.8, a power ratio of 2 expressed in decibels is, now that's using the same equation that we did here before, dB equals 10 times the log of the ratio, dB equals 10 times the log of 2, so let's do it. 10 times the log of 2, so all clear. 2 log multiplied by 10 equals 3, close enough to 3. So a numeric ratio of 2 is represented in decibels as 3 dB. Again, we're doing exactly the same thing. We're using this equation up here, dB, a power ratio of 1,000 expressed in decibels. Well, that's 10 times the log of 1,000. I know the log of 1,000 is 3 because 1,000 has 3 zeros, but I'm going to pretend I don't know it. All clear? So 10 times the log of 1,000. So we'll put 1,000 in. We'll put 1,000 in first. We'll get its log, which should be 3. We multiply by 10, which of course will give us 30. So the answer is 30 dB. And another one, all the same. These are all the same using this equation here. dB for power is 10 times the log of the ratio. In question 1020, we're told the ratio is 100. The log of 100 is 2. And then we've got to multiply that by 10. And that would be 20 dB. Now I'll do it on the calculator. All clear. Enter 100. Get its log. Multiplied by 10 gives us 20. Question 1021. A power gain of 1,000 is expected. Well, that's the ratio. Oh, sorry, not 1,000, a million. A power gain of 1,000,000 is expressed in decibels. Well, I know the log of 1,000,000 is 6 because it's got 6 zeros. But I'm going to pretend I don't know it and do it on the calculator. So I'm going to enter all clear. I'm going to enter 1,000,000. I'm going to get the log of it, which should be 6. I'm going to multiply by 10, and that will be 60. So the answer is 60 dB. Question 1022. The unit commonly used to state the gain or loss of power or voltage, and current too for that matter, is the decibel. Well, that's it for this section on mathematics. It's not a comprehensive tutorial on mathematics. It's just enough for you for your assessment. If you're having trouble with logs and exponents and all that, if you can remember the sorts of equations and problems that have been done during this tutorial, you should be alright during your standard amateur radio assessment. Thank you very much for watching tutorial 13. Test yourself on drill number 10, and I'll see you back in the next tutorial. Cheers for now. This is Ron, VK2DQ. I hope you're enjoying your course.